Well, welcome everyone. We want to welcome you to our February 2023 edition of the Research to Implementation webinar series here from NCAT. We've got a great topic today. I'm super excited about it. It's the use of smaller or fine screenings in our mixes for pavement preservation. So again, this is going to be, thin lays discussion, preservation, and using some of those really small nominal maximum aggregate size mixes. And we found some really great success with those, not only in the research that we've done on the NCAT test track, but also what we've done with our off-site tests, the things like Lee Road 159 and our work in Minnesota. And then we've got a special guest today that can talk to us about some of the ways that was implemented at a DOT level. So as always, I'm going to introduce everybody, and then we're going to kind of go down through the list here. We're going to have Buzz start off, and then we'll go with Adriana next, and then our special guest, James Williams. He works for APAC now, but he used to be part of the Mississippi DOT. So as always, please put any questions that you have in the chat box. We'll try to answer those kind of on the fly as we can, but we'll take some time near the end to go ahead and follow through with those again and go from there. So without a further ado, Buzz worked for 12 years with the Alabama DOT and 2 years as a private consultant in the private sector before coming to NCAT and becoming the first test track manager in 1999. He's now an associate director with NCAT and also an Auburn University research professor. And Dr. Adriana Vargas, she received her master's and her PhD at Auburn. She worked as a private consultant before she came back to school here at Auburn, and she also was a professor at the University of Costa Rica. She's currently an assistant research professor at NCAT. Her main areas of research are pavement preservation and pavement management. In fact, she's got the pavement management class on campus this semester. She's the lead PI for the NCAT and Min-ROADS Pavement Preservation Group study, which is a pooled fund. And really the goal of that is to try to find the life extending benefits of the various treatments, looking at both the hot environment in the south and the cold environment in the north. So, and then our special guest today is Mr. James Williams from APAC. He is a registered professional engineer with 31 years experience. James served in various roles in the Mississippi Department of Transportation, including the state geotechnical engineer, the state materials engineer, and ultimately he ended up being a deputy executive director or a chief engineer. And now James works for APAC Mississippi Incorporated, and he serves as their engineering manager. So please keep yourself muted if you can. Type your comments in the chat box or your questions in the chat box, and we'll go from there. So Buzz, take it away.
Well, thanks, Travis. As always, I'm going to start out by providing just a little bit of background, and then our PI, Dr. Adriana Vargas, will come in and she will discuss the research that we've done with these types of mixes. We'll have some discussion on practical use, and then finally I'll come together in the end and provide some takeaways. Of course, all this starts with the test track for us, and I sort of grew up with the Alabama DOT, and I had frankly a bias against the performance potential of the types of mixes that we're discussing today, the smaller, finer screenings type mixes. I was sort of taught in the DOT, well, these mixes are okay for low volume roads, but they really we have to be careful in how we use them when we have higher traffic volumes. But the track completely changed my mind about that. We like to say that we're data people. We let the data speak with the research that we do at the NCAT pavement test track and on the off-track test sections that we've done, and that certainly is the case for the mixes that we're talking about today. So I'm going to go through the track history, the background of our experience with these types of mixes. For us, it all goes back to test section W6 on the 2003 track, the 2003 3-year research cycle. and then everything else that we did on the track and off the track is sort of a cousin to that mix that we put on the track back in 2003 that is still there, by the way, 20 years later, and 65 million easels plus or minus later. So this mix was a limestone screenings and sand mix. The screenings, it's 70% limestone screenings, 30% hard sand. It's a it's a natural sand, but it's a processed sand, so it's really angular. You can kind of think of it like a processed gravel screenings type material. And it was a 475 in mass mix that we put on the test track in a 3/4 inch lift for the state of Mississippi. That was in 2003 on section W6. So fast forward now, the '03 track, the '06 track, and the '09 track, after 30 million easels through those three research cycles, that mix just really looked armor plated. It was providing good friction numbers. There's no cracking, there's no rutting. It just looks spectacular. It is on a perpetual foundation, but that's because, when you have things on the track on a perpetual foundation, it's because you're really trying to isolate the stresses to the surface layer or layers, and that certainly is the case with this test section. So in 2012, after those three successful research cycles, the state of Mississippi came back and said, hey, we would like to create a mix that can either be a mix specification that can either be a 475 or a 95. There's some flexibility there so that our contractors can use some of the gravel sands that we have that are just sort of scrap stockpiles that are left over from our super pave aggregate processing. So we're building up a surplus of those materials. That mix had wrap in it. I think it was 25% wrap, 20 or 25% wrap. And so we put that on the track in 2012. It's still there. So section W6 and section S3 are still on the track, and they're still performing well. In 2012, we went off track to do our first pavement preservation experiment. That was on Lee Road 159. So we looked back at our experience on the track and said, well, that limestone screenings and sand mix in W6, it still looks great. Let's use that mix. It's really easy to run. It's very predictable to run. And so we use that sort of as our core thin lay mix on Lee Road 159. There's several different versions of that mix with different types of binders, and also one version of it that is on a 100% wrap cold recycle mix. But there's a wrap version, a high wrap version is 50% fine fractionated wrap, and then there's a 5% post-consumer shingles version of that mix. All those mixes are still in service on Lee Road 159, and this summer will be 11 years. So go one step farther to the 2015 3-year research cycle on the track. And Tennessee looked at what Mississippi had done in W6 and what they had done in S3 and said, okay, well, in section S4, which is test section number 4 on the south tangent, we want to do the same kind of thing. We're going to do a limestone and sand mix, not the same limestone. This is Tennessee limestone. It's going to have wrap in it, and it's going to be a 475 thin lay. I think it was an 1.25 inches thick. They wanted to see could they use it in a little bit thicker lift, because everything that we had previously done had either been 3/4 of an inch or 1 inch. That mix did well, had no distresses. We just replaced it for the current research cycle, but it looked great at the time that it was removed. Also in 2015, we did preservation thin lays, these screenings thin lays in high traffic test sections that were part of the preservation experiment on US 280. And in this mix, we had the virgin versions of this mix that were, a cousin to W6 like everything else. But we also had a balanced mix design using the technology that we had available to us at the time, by trying to optimize the amount of wrap and RAS that we put in that mix. So instead of, like on Lee Road 159, we had a 50% wrap and we had a 5% shingle mix. On 280, we ended up, I think, with 11% fine fractionated wrap and 3% post-consumer shingles, as we subjected it to a balanced mix design process. In 2016, as part of the Minroad partnership, we mobilized to go up to Minnesota to support our partners up there in the construction of pavement preservation test sections, emulsion sections, and also thin lay sections. And so we did the wrap RAS version of all the thin lays that were on 280. We did the same thin lays and the same combinations on County State 8 Highway 8 and on US 169 up in Pease, Minnesota, using regional aggregates and regional binder grades. But again, with great success, all those test sections are still there and they're still performing well. In 2019, then we went back up to Minnesota and we did another version of those same mixes, those peas mixes that we had placed in 2016 in a recycle experiment on 70th Street, which is the access road to the Monroe test facility. So we put a 1-inch thin lay on top of all the cold recycle sections, also with just a 1-inch control and a 1-inch over hot mix control. That mix that we did on 70th Street did not have any post-consumer shingles in it. It didn't have any shingles in it at all. It was a wrap mix, and I believe it was 20% processed wrap that we included in that mix, just 1 inch thick. Those mixes are still there, still look great. And then finally in 2021, on the off ramp at the test track, when we did our 2021 track build, we put the same mix, that W6 mix, as a surface mix, a 1-inch surface mix on a whole variety of cold recycle test sections, so that we could really put it to the test under heavy truck traffic. But the off ramp only sees something like 1.5% of the traffic that the track sees, because we only use it when we're getting trucks on and off the track. Of all the experience that we have with all these screenings type thin lays, really the only two that were disappointing, that are still in service but with a lot of cracking, are the 50% wrap and the 5% post-consumer shingles mixes that are on Lee Road 159. And those mixes were volumetric designs. They were not balanced mix designs. So we just dropped that material into those designs. So a lot of history with these smaller, finer screenings type mixes. Now I'm going to hand off to Adriana so that she can do a deeper dive into the research.
Okay, good morning, everyone. I hope everyone can see my screen fine and can hear me okay. I'm gonna be talking about the thin lays and emphasizing what we have done for the PG study, since those were specifically with preservation in mind. But I wanted to start by giving just a quick recap of what those thin lays are. So when we're talking about thin lays for preservation, I think if you ask anyone what a thin overlay is, you'll get different answers. There's not really an official definition, but we're generally talking anything less than 1.5 inches. So probably somewhere around 3/4 of an inch to 1.5 inches. Most of our thin lays are 3/4 of an inch. We have a few that are 1 inch thick. So 1.5 inches will be on the thicker side of the thin overlays. If we are going that thin, we're going to have small sized aggregate to be able to accommodate the thickness to nominal maximum aggregate size ratio. So in our case, our thin overlays are 4.75 millimeters, as Buzz was saying. The binder and everything else is selected just like you would with a normal design. So you can have neat binder, you can have polymer modified binder, you can have wrap and ras, as Buzz was saying. If you properly design, hopefully you can get the best out of it. But essentially, you're just doing an asphalt concrete and placing it very thin. When do we want to do a thin overlay pavement preservation treatment? Well, even though they're overlays, these are still functional. So we want to have a pavement that is in good structural condition. It can have some distresses, but they should not be load related or structure related. You have to have a good pavement. to put in over if you want to get the best out of it, if you're truly doing pavement preservation. Where do we want to use them? Well, we can address things like raveling, oxidation, minor cracking, minor surface irregularities, skid problems. Those are all things that you can address with a thin lay. And as you will see later on, we can also put them as a wearing surface on full recycled basis, which is what we did on US 280 and 70th Street in Minnesota. And how we do them, it is not that different from just doing a regular paving lift. But there are things that you have to watch out for during the whole process. So for production, for example, if you're going to use the finer aggregate, it's easier to have moisture accumulate in those finer stockpiles. So that has to be controlled rigorously. This is one type of mix or one type of application where using warm mix additives as a compaction aid can be very beneficial. They are going to cool down very quickly. So that brings me to the next part, placement and compaction. Surface preparation is very critical. Delamination could be a problem. You're going to pave real thin, and that interface is going to be very close to where those forces happen that will cause slippage. So you want to be very careful when you're cleaning up the surface and applying your tack coat. These are things that you always have to do anyway, but you have to pay special attention if you're doing a thin lay. And then if you're doing it thin, the heat's going to dissipate faster, exponentially faster when you're doing something like this. So you got to be ready to move on to the compaction process. And this is where the warm mix additives may be beneficial to help have more workability and just longer time for your placement and compaction. For quality control, it's hard to measure density in such a thin lift. You want to monitor consistency. So be sure to just be achieving consistent results. Now going into our preservation thin lays for the PG study, we have test sections like Buzz was saying here in Alabama and Minnesota. Most of them are 3/4 of an inch in thickness. With the exception of the ones that are on top of cold recycled bases. The nominal maximum aggregate size is 4.75 millimeters, like I said. And for materials, again, like Buzz was saying, we have virgin materials, we have asphalt binder replacement mixes that have wrap and RAS. We've used neat binder, polymer modified, and highly modified binders. And from all of the sections that we have, they're ranging between 3 to 10 years in service. Actually, it's closer now to 4 and 11, but you can see it's a wide range of performance periods that they have been in service. And then we've placed them either over the existing pavement with and without micromilling. We've placed them on top of chip seals. We've placed them on cold recycled bases. So they are very, it has a lot of applications, I guess is what I'll say. So just for an example, these are some shots of our test sections, and you can see now we'll have at the top our Minnesota sections. On the left are low traffic, on the right are high traffic. And so the ones at the top are the newest ones. They're about 6 years since they were built. Lee Road 159 is 10 years in service, and then 280 is 7 years in service. So thinking about that and how they look at this point, I think they have been doing a great job. We see a little bit of cracking in some of the areas. Minnesota, for example, has very aggressive thermal cracks, and that's going to be reflected no matter what. But the thin lays have been very effective in controlling the severity of those cracks and helping in turn just having smoother pavements compared to a pavement that didn't get anything done to it. So for the most part, they're in good condition. We use the MAP 21 performance indicators. So cracking for most of them is less than 5%. of the total area, ruts less than 5 millimeters, and IRIs under 95 inches per mile. We have a little bit more cracking on Lee Road 159, just because it's older, so that's to be expected. But it's still, everything is looking really good, doing its job. The next one here, to hide this controls. Here we go. This is an asphalt binder replacement thin lay. So this one will have wrap and RAS, like Buzz was saying, used with the balance mix design, or design with that approach in mind. So we were able to optimize the use of recycled materials. And as you can see, they're also getting very good performance from the mixes. Perhaps a little bit more cracking is to be expected compared to the virgin materials, but still just over 5%, far from the poor condition threshold, which is 20%. We do not have one of these overlays with the ABR design for Lee Road 159, which is where we did our first sections. So in there, as Buzz was saying before, we have the 50% wrap and 5% RAS. And I'll show you what those look like today. Not really ideal. So a lot of cracking. Obviously, these are mixes with a lot of aged binder in them. So they're going to be a lot stiffer, more prone to cracking. And that's exactly what we saw. So at this point, they are both cracked beyond the 20% of the total area. They're still functioning, and they have decent ride numbers. So it really hasn't affected much other than, well, we have all this cracking in the surface. So at this point, you probably wouldn't want to have a surface like that. We'll be thinking of doing something else to it if you're an agency. So this is what happened. Doing just the volumetric design and substituting the material. We learned from that. And as you could see in the previous slide, we had really good results when doing balance mix design and optimizing those proportions. One of the cases where we have put thin lay on a chip seal, in this case is the thin lay on fiber mat chip seal. It's helped again with performance. You can see the indicators. We have a little bit more roughness in some of the areas, but still within an acceptable level. They have maintained a somewhat constant ride indicator. A little bit more cracking on 280. I think that was on my part a little bit unexpected, but we also have to think of the initial condition of that pavement and how cracking performance is tied to the condition of the pavement at the time of treatment. So these had a little more cracking, and that's why we chose the combination of treatments. But still, overall, they look good. We also have a thin lay on US 169. It's on a regular chip seal, so not a fiber mat, but we have similar results. So overall, we have a nice surface, less cracking, or when we do have cracking, it's less severe, overall protecting that pavement and doing its job. For the thin lays on the cold recycle basis, I think the big question here was, well, we're doing this cold recycle base. How thick does that wearing surface have to be in order for it to provide good service? So we put down 1 inch on a highly trafficked road. And you can see there, now this is for 7 years. So I just took these pictures last week. For the most part, they're doing good. We have some cracking. This one on the thin lay on foam CCPR, we can see pumping and a lot more cracking than any of the others. But I should point out that this section has a slightly different structure than the others. So it's overall thinner We have variable thicknesses along US 280. So the other three sections are more uniform, all of them, and thicker than that first one. So that's also tied to that structural performance. Overall, it just has less strength. We also see cracking here for the thin lay on emulsion CIR, no pumping, and really the cracking is still pretty fine. So it has protected that core recycled base, and it's done a good job. But I think in terms of how long was that good for, we're probably approaching that threshold in terms of those performance indicators. We also have a thin lay on foam CCPR for Leroy 159, and it's actually thinner, only 3/4 of an inch, and it's been down there for 10 years. So this is a lot less traffic, heavier loads still, because we have a lot of loaded trucks going in that lane. But you can see there, excellent performance. We have maybe a couple of cracks after 10 years, but overall, it's done a great job. So low traffic setting, it's definitely been very effective. So looking at the benefits, we want to ask ourselves, well, what are we concerned about? And in the case of our study, we found that performance means different things for different people. So for the warm climate here in Alabama, we're concerned with oxidation, cracking, and cracking mainly along the wheel path, so fatigue cracking. For the cold climate, roughness is really their driving indicator, and that is really tied to thermal cracking. So transverse cracking and how rough pavements get from that. So it's important to do that benefit quantification in terms of what's relevant for each location. So I wanted to show a few examples from some of the low traffic sections. The virgin thin lay, for example, how is it doing in terms of cracking? So we have on the left, Lee Road 159 here in Auburn, and then CASA 8, which is the equivalent county road, but in Minnesota. And you can see how cracking progression has gone. In our case, we are here at year 10, and we have reached the about 10% cracking. So that will be in the fair condition threshold. The red line is the control. So this is what will happen if we're not really doing anything. And then the blue is the treated pavement. Same thing goes for CASA 8. So in their case, what happened was that the reflective cracking from those thermal cracks would happen. So they will reflect back, and then it just kind of stopped. Nothing else happened. So that's why it's kept kind of constant over time. So at year 6, they're still in good condition. And then the control has a lot more cracking, but not as bad as what we had for Lee Road. But if we did our benefit estimation in terms of that, what we do is we look at the time that it takes for the pavement to get to that poor condition threshold and the difference between the treated and the untreated. So in the case of Leroy 159, the control section reached the poor condition at just over 2 years after we started the study. Pavements were already 14 years old. And then at year 10, the treated hasn't really gotten there yet. So all we can say right now with a lot of confidence is that it's going to be more than 8 years of life extension if we go with that definition. We can extend this and extrapolate. I think if we have more data, we can feel better about the extrapolation, but right now, definitely more than 8 years of life extension. For CASA 8, it's hard to predict at this point. So you can see those lines are pretty flat, and even going to year 10, it's nowhere near that 20% threshold. So in terms of cracking, it's still hard to make a prediction at this point. But like I said before, for the northern climates, IRI is a lot more relevant than cracking is. So we want to look at IRI and what's happening with those sections. You can see here at the top, the CASA 8 section. So we have a treated pavement and an untreated pavement with the dashed line. So this is the control, what's how IRI is going to progress over time if we don't do anything. And then with the thin lay, we were able to, number one, get that IRI just corrected and dropped significantly just immediately after construction, and then over time kind of sustained that deterioration rate. Then for Lee Road 159, it didn't make that much of a difference. We were pretty good to begin with. So we put down the thin lay and obtain a minor benefit, but the important thing is that over time we've stayed pretty constant. So in this case, for the Minnesota section, we're projecting, if we were to extrapolate, life extending benefit of about 3 years and an average condition improvement. So the difference between those two lines over time is 55 inches per mile. So that's pretty significant since IRI is such a big deal for the Minnesota folks. In our case, nearly constant over time and a slight ride improvement, which I think we'll take it. So if we want to quantify in terms of cracking for our southern sections, here's a summary of what we have. So what I want to point out here is that we see a lot of 10 pluses in that table. The two that didn't perform that well and they have already gone to the poor condition category, so more than 20% cracking out of the 50% wrap and 5% RAS thin lays. And the others are still going strong, and I think we'll continue to see good performance out of them. Now for the Minnesota sections, we have the same type of estimation, but in terms of IRI. So in this case, where we really have them in service for 6 years, we're projecting to 10 years and see where that goes. But at year 6, they were all still either in good or fair condition category. So making the projection to year 10, there's still some of them that are going to be going way more than that. So we have the virgin thin lay and the ABR thin overlays, and they started in good condition, so it's easier to keep them in that good condition category. We have a combination of a thin lay on a scrub seal, and even though it was in fair condition, it still seems like at year 10 we're still going to be below that threshold. And then the others, if we start in fair condition, probably the benefit is not going to be as good, but we're still seeing good estimates, 7.5, 8 years and beyond for life extension. So it seems to be consistent in terms of what we're expecting for that range, even though we're using different indicators. I wanted to let you know that we have developed this online tool. You go to ncat.us, there's a payment preservation tab at the top. So if you click on that and then on the left-hand menu, you go to observe performance, you can explore some of our results in a more interactive way. So you can select the treatment that you're interested in, the initial condition of the pavement, and then get things like this with the performance curves and the indicators and see just how they're performing at this point in time. So this is a good tool to kind of play with, to explore if you're interested in just seeing more details from our test sections. Right now we have it for Lee Road 159. We're in the process of getting this together for the other locations, but you can see things like, well, how long did it take for the untreated pavement to get to that poor condition threshold? How long for the treatment? In this case, it's a virgin thin lay and it hasn't gotten there yet. And the average crack reduction over time, or you can select a particular point in time where you will want to see that. One more thing that I wanted to bring up is texture and friction, because that could be a concern. We're doing sections that are very, or aggregates that are very fine. So that could definitely have an effect in texture. And we do see that. So this is again, an example from Lee Road 159, the virgin thin lay. This line here with the dashes is the original macro texture of the pavement. And then as we put down the thin lay, that dropped quite significantly. And then it started to, as we started to wear off some of that fine aggregate matrix, we're starting to gain texture and getting close to that pretreatment value. So that could be a concern if we just think in terms of texture. But if we look at friction, it hasn't really been affected. And I'm not showing the numbers. We typically don't disclose that, but I can give you as a point of reference what our warning and critical levels are. So you can see we're good in that sense. We dropped a little bit in the beginning as the macro texture dropped, but then we're able to sustain and be always above those levels. And we have, that will be Lee Road 159 with low volume. What happens in a higher traffic setting, that could be more critical. So I use the same virgin thin lay for 280. And again, we see a reduction in macro texture as the treatments are placed. But then for friction, it doesn't really affect it. So we can be at ease that it's really not going to be much of a concern for friction performance. Friction takes into account macro texture as well as micro texture, and it will be probably more sensitive to the micro texture than it is to macro texture. So it could be affected, but it doesn't seem to be that closely related in this case. So to summarize here, we have those thin lays as really effective preservation options. We can also use them to protect those cold recycle bases and address different issues like I showed. They have shown significant life extension, which is good. And as far as producing them and placing them, it's very similar to any asphalt paving operation, but we want to be especially careful in some areas. And we haven't had any friction problems resulting from application of those finer mixes. So with all of that, I think pretty much summarizes our experience from the pavement preservation study side. And I think, is it James' turn?
Okay, hopefully everybody can see my screen. It's a pleasure to be here today. And thanks to Buzz and Adriana, they did a wonderful job kind of sharing some of the performance aspects of what we've actually seen in Mississippi. So I'm going to shift gears just a little bit and kind of talk about how Mississippi kind of approached implementation of thin lift asphalt. So what I'm going to do, I'm going to kind of break it down into the why, where, what, and then kind of finish up with some of our experience with performance. So you can't really talk about the why without, from an agency perspective, kind of talking about funding. And obviously, you know, over time, we've dealt with increasing construction cost. And even though revenue is ticking up in a lot of states right now, with inflation as it is, you know, we are always battling kind of that doing more with less. So that is something that definitely plays into the why of thin lift asphalt. Adriana did a really good job kind of communicating the concept of pavement preservation. I won't really go into that, but obviously from a state agency perspective, if a state agency can keep good roads good and avoid kind of that reconstruction, what we found in Mississippi, that reconstruction cost could be, 10 times, as much as 10 times the cost of, doing routine preventive maintenance. So all of that considered, that kind of goes into the why from an agency perspective. But thinking about the traveling public, with thin lift asphalt, what we see in Mississippi is we're routinely measuring 30 to 50% ride improvement, even though we're only paving at times 3/4 of an inch with our thin lift asphalt. So there's obviously some benefits to the public related to ride. Also, what I've found over my career with public perception, when you pave a road, whether it's a thin lift or you completely reconstruct or you do a mill and inlay, the traveling public feels like that's a new road. So the thin lift definitely kind of fits that bill as far as kind of perception with the traveling public. Also, some benefits to the traveling public. Obviously, we're preserving the underlying paving structure. As Adriana and NCAT have shown through their preventive maintenance research, that pre-treatment condition does matter. So we need to apply these treatments at the right time. But with these thin lift asphalts, we see lower permeability. So we're protecting, keeping that water out of the pavement structure. We also see that these mixes are very crack resistant. And I think that's really due to the fact that in Mississippi, while we allow 25% wrap, we're getting more AC in those mixes. So with the idea of balanced mix design coming down the pipe for agencies and for producers and contractors, these mixes just appear to really fit that bill from a crack resistance standpoint. Also, kind of on the why, if as Adriana showed, we're seeing very, very good performance out of these structures. So if you kind of break it down, I like to think about with life cycle cost, kind of a cost per square yard per year. While a thin lift asphalt may have a little higher initial cost than some other preventive maintenance treatments, if you apply a thin lift on a road that's in fairly good condition, it can easily, as we've seen with W6, as Buzz talked about, that's got over 65 million easels on it, S3 that is somewhere, I'm guessing 20 to 30 million easels. So these mixes in the right conditions will last a very, very long time. So if you spread that life cycle out over a long time, you actually get a really good cost per square yard per year if you kind of break it down that way. One thing we've also seen, and this was due to some of the work over at NCAT, in Mississippi, we are doing a lot of kind of combination treatments where you have a road that the pre-treatment condition is maybe from a cracking standpoint is a little further along than you would like. We've seen very good performance doing scrub seals to try to seal those cracks up and then doing a thin lift overlay over that. Those combination treatments seem to have some synergy that gets really, really good performance. Spend just a minute talking about the where. When we started this back to 2003 with W6, we kind of viewed thin lift asphalt as a low volume road mix. And what I mean by low volume road, the state highway system, for instance, in Mississippi, we call them 3-digit roads. They're kind of collector roads. We have a lot of farm to market roads. Those low volume roads, a lot of times they don't have a lot of truck traffic either, if it's outside of our agricultural areas. So that really was a niche that we wanted to kind of catch with the thin lift asphalt. At the time, some of these lower volume roads were on a maintenance cycle of maybe 30 to 40 years based on funding. So we were really looking for a niche to spread our money and go about taking care of these roads. And from a preventive maintenance standpoint, the thin lift kind of fit that mold. But I've got question marks on the low volume routes, because what we saw with W6, and then we replicated that with S3, we saw really, really good performance under high traffic. So if the mixes are designed appropriately, I'm not sure this thin lift asphalt is a low volume road mix. It can be used in a lot of different applications. And in Mississippi, we've actually used it actually on interstates for leveling and doing some things. We may not put it on the surface because of some of the other issues that Adriana kind of touched on, but we have put it in higher traffic, higher truck traffic type areas, and it's worked very, very well. Roads that are structurally sound. Obviously, if you have rutting and you're trying to put a mix down at 3/4 of an inch, you can have some issues there. If you have structural cracking, that would be an issue where, you know, I know a lot of times state agencies get in the position of just having to do something. But if you really want to set a thin lift asphalt up for success, you know, make sure that you have that minor kind of top down cracking, and little to no rutting. When you talk about the where, it's extremely important to have good data. And in Mississippi, we've been very fortunate to have very good system-wide pavement management data. The Mississippi DOT did a great job developing distress decision trees that helped kind of give that menu of treatment options for various types of pavement distress. Thin lifts were built into that probably a decade ago. So that kind of gives you a time frame of how long Mississippi DOT has been using that as one of the options for preventive maintenance. Obviously, kind of using that preventive maintenance or pavement preservation motto, the right treatment, the right time to extend life, treat pavement distress, minimize life cycle cost, all of those things apply. And again, what I have seen personally, and Mississippi DOT has seen, you know, these combination treatments on roads that are maybe cracked a little bit more than you would like seem to work really, really well. I'm going to shift gears just a little bit and talk about the what. And what I really want to focus on here is the partnering effort with industry and the state agency. The mix that was put in W6 was a 475 super paved design. In the mid to late 2000s, what happened in Mississippi is we started the policy of using SMAs and OGFCs on our interstates. What that resulted in was these huge mountainous stockpiles of kind of byproduct materials at our aggregate facilities. And a lot of times that material was, you could call it manufactured sand, you can call it 3/8-, you can call it screenings, you can call it whatever you want to call it. But that was kind of a byproduct of starting to use these SMAs and OGFCs that were more of a gap graded type material. So that really led to a partnering effort. And what you find is that as we kind of go through some of the general specifications. What we really set out to do was to allow the producer to design a mix that would perform, but really optimize the materials that they had on hand to try to control cost. If a producer can use a byproduct that couldn't be used for something else, typically that helps with cost. So one of the things we did is we allowed the designer, based on the materials that they had, to kind of design between a 4.75 and a 9.5. Most of these materials, or most of these mixes, fall somewhere in between because we're using a lot of that manufactured sand or that 3/8- material. We also looked at air voids, and one of the things we looked at related to air voids was the permeability. And what we found was that even at, say, a 6% design air void, we were still getting very good permeability performance with those mixes. So we allowed the designer, based on their materials, to design somewhere between 4 and 6%. We allowed 25% wrap. What we saw in Mississippi was that most of our producers, either through the specifications or through just their normal use, were crushing, processing, screening wrap. And so we said, okay, let's allow wrap to be used up to 25%. Typically that's a fine wrap, and it helps with that virgin AC. So that helped control cost. And then we allowed up to 30%, as Buzz said, kind of a hard sand. We allowed that. Sand is the cheapest product we have. Then on the construction side, lift thickness, in the specifications we put, from a 1/2 inch minimum to 1 inch. In reality, 1/2 inch is too thin. Typically, Mississippi DOT is specifying 3/4 of an inch to an inch. A lot of times these are 3/4 of an inch in variable type mixtures. A lot of times this is done as a single lift overlay, although a lot of the jobs now are kind of a combination treatment depending on the pre-treatment condition. Then Adriana talked about density. In the specification, there's a monitored roll to refusal with that material. That seems to work very, very well. And then smoothness, the only smoothness requirement in the specification, because this is preventative maintenance, was just don't make it worse, right? So that was kind of the approach with the specification. But in reality, what we see is we do see routinely about a 50% improvement. So shifting gears to performance, S3 at the end of the 2015 cycle, this was a statement that was in the track findings report. And as you can see, after 20 million easels, there was essentially no rutting. The amount of cracking was less than 0.2%. Very, very good, solid performance. I will tell you, during the planning process for S3, we actually doubled the material to make sure that if the mix did not perform through an entire 10 million easel cycle, that we have material on hand to replace it. And it's still in place today. So just a testament to the performance of that mix using local materials. And I'm going to finish up with some recent success. As Travis mentioned, I now work for APAC, Mississippi. And in 2022, we paved a state highway. It is a fairly low volume road highway, but this particular road got a Napa Quality and Construction Award, and also got a MAPA Quality Paving Award for this past year. Just a little bit of notes about the job itself. This particular job, because of the pre-existing condition of the pavement, the DOT decided to do a 3/4 inch leveling lift with that thin lift mix, and then overlaid the entire job with a 3/4 inch surface. So structurally, that wound up being 1.5 inches of mix, but in reality, a great job. Just from a smoothness standpoint, overall, there was a 72%, 73% improvement on the ride. And on average, across the entire job, the RRI was a 30.8. Extremely good job. This is typical of jobs that we're seeing in Mississippi with the thin lifts. And with that, I'm done unless there's any questions.
Let's go ahead and hold questions to the end. There's one that's come in on the chat box. Let's have Buzz do his little piece and we'll go from there.
Perfect.
I think you'll need to stop sharing. There we go.
Well, thanks for that great information, and so I'm gonna come here in the end. And try to kind of pull all this together with some important takeaways for attendees related to these smaller, finer screenings type preservation thin lays. Well, you know, we've got track proven performance for these mixes. You know, we always say we do 3 types of research. We do mix and materials research, milling and inlaying. We do structural test sections, and then we do preservation research. And these mixes very much fall into the preservation toolbox. Have a long history of good performance with these mixes everywhere that we've put them. As I mentioned earlier in my part, the only place really that we've been disappointed is when we had the volumetrically designed 50% fine fractionated wrap and 5% post-consumer shingles. And when we went back in and did a balanced mix design with that later, that was on 159. When we moved out to 280, we were very, very pleased. So we've had good performance in both of the climate extremes in the Gulf Southeast and then in the frigid north.
Ooh, sorry there. Can everyone see the presentation?
Right now, we see just the people, Adriana.
Okay.
Using regional materials for us down here, as well as regional materials up in Minnesota. We've done these on test sections that vary between perpetual sections like section W6 on the track that sort of started all this, all the way down to 4.5 inches thick, which is the thickness of the structures up on 70th Street up in Minnesota. Lee Road 159 was about 5.5 inches thick, but the thinnest we've done is 4.5 inches on 70th Street. Traffic has ranged from low to high, you know, low traffic on Lee Road 159 and County State 8 Highway 8, all the way up to really high traffic on US 280 and US 169 in both of the climate extremes. We've done this directly on top of both hot mix and foamed cold recycle mix, emulsion cold recycle mix, and we've done that in the hot climate and the cold climate. And we've also done it on, we've done the off-ramp preservation test sections at the track on top of engineered emulsion and engineered emulsion plus recycling agents, and then also just recycling agents in addition to foam, and had good performance with all of those configurations. This allows us, like what happened in Mississippi, as was described in Mississippi, to utilize our screenings that really are building up surpluses in a lot of regions. Not everywhere, but in some states, in some of the stone states, you see, kind of screenings mountains that have built up over time that are similar to the gravel screenings type surpluses that built up over in Mississippi. These mixes allow us to use those types of materials because they are smaller and they are finer. Like what happened that was described in Mississippi, they created a relatively open specification that where it could be either a 475 or a 95, but it was a great way to use those materials. The only caution that I would provide with these mixes is that they are low macro texture mixes, these dense graded 475 preservation thin lays. So if you need macro texture, if you need somewhere for the water to go to stay out of the pavement tire interface, like if you got high speeds or if you have sharp curves, just make sure that you understand that low macro texture is a feature of these mixes, and you need to understand that when you specify their use. So in the preservation study, as Adriana described, we've got really good information on the life extending and the condition improving benefit of these mixes, like we do with all the other emulsion treatments. And I think it's a really important option in our pursuit of safe and sustainable asphalt pavements at the lowest possible life cycle cost. So very good story, very good message, and we appreciate all the speakers' content for this webinar today. So there's our contact information if you'd like to follow up with us directly, and if you know for some reason you don't have time to hang with us for chat answers to your questions, or if you just would like some additional information, we appreciate all the content that was provided today by our speakers. Before I hand off to Travis, I always make a plug for the product that he's developed for NCAT as our training director, Training in Your Pocket. This is a really great tool for new people that are coming into our testing programs, as well as for some of our veterans, just to have a little bit of a refresher and a little better understanding. These are amusing and engaging videos on many different types of topics that I think you'll find to be very helpful. And finally, before I hand back off to Travis, we want to give a plug to our next webinar, which is on March the 16th, and that one is on maximum thickness for perpetual pavements. And Dave Tim will be our PI presenter in that webinar. So back to you, Travis. Thank you very much.
Sounds good. Thanks, Buzz. Just wanted to grab a couple questions real quick. We're past the top of the hour. I always like to get done as soon as we possibly can. One question, James, I want to throw it to you real quick, being a practitioner there in your past, is if we have a thin lift that we put down using these finer gradations like this, and it lives its life out in that 7 to 10, whatever we may years beyond that, do you recommend milling that off before you replace it, or would you go over the top of that again, or would you just say it depends?
I think it obviously depends, Travis, and it kind of goes back to the state agency's pavement management data and what triggers they set up. You know, what criteria they use to determine if a pavement needs to be milled or not. Now, we'll put a plug in from a producer contractor standpoint. I know in Mississippi we need to mill more, and there's a lot of reasons for that, but one is as we look at carbon footprint, we look at EPDs and some of the things that are being presented on a national level. Really, one of the ways to really cut at that is to use more recycle in our mixes. So I would put a plug in for that, but to answer the question, it depends.
Yeah, I agree, especially from my experience in West Virginia. You know, if it's in good shape still, you know, and it is that right road for that treatment, I think just overlaying it is great, especially if we have no debonding issues. We had some debonding issues in some of the projects I dealt with. The other one that was on here real quick that I want to make sure that we get to you is does Mississippi use non-polymerized asphalts in thin lift? Or are there any special traffic restrictions that you guys use?
So there are some traffic restrictions. Typically these mixes, because as I said, they started off being low volume road type mixes. So we have mostly used non-polymerized asphalt in those mixes. With that said, I think the DOT now would, in the right application, kind of push that envelope traffic wise. So we actually in Mississippi have a map that shows the routes that would have to have polymer included in the mix. So it's not that it can't be done. It just right now on most of the roads it's being done on, it's non-polymerized.
Yeah, yeah, I get that for sure. You know, we put it on I-70 in West Virginia. You know, that's a pretty major east-west carrier, especially freight-wise. We also put it on I-64, which is one that's kind of a diagonal that comes through Kentucky and down into Virginia, and found great success with it there on those interstate type traffic.
Yeah, 100%. They can certainly be designed for the traffic.
Yeah, for sure. Adriana, I want to throw this other one. I'm going to bounce two of these together. I want to see if you can give us some insight here. Do you feel like there's any optimum gradation or any considerations that we really need to look at with our gradations as we do these finer mixes?
I think we have to use the same requirements that we would normally have for any asphalt mix. I don't know if James, in your experience with the DOT, if you had anything in the spec that was different, but I think overall it's just asphalt.
I would agree. One of the things we really focused on was trying to use some of those kind of byproduct materials. So we did allow some adjustment in kind of that master gradation table. So it's not exactly a 475, it's not exactly a 9.5, but if you kind of design around that maximum density line like we always do, then your same volumetric properties apply. So that would be what I would say about that.
Great. And I think one consideration that needs to be explored, if anybody's trying to put a specification together to use these mixes, is that macro texture becomes important, like Adriana was showing. You know, you need both the friction from the aggregate to the tire, but you also need that macro texture somewhere for the water to go. You know, we did have a project once that I dealt with where we didn't have the macro texture necessary on a thin lay like this, and we ran some semis off the road in the rain. It was not a fun time. So, given that, I want to thank everybody. I want to thank Buzz, Adriana, and James for all the information that you guys have given us today. Again, put a plug for that the upcoming webinar that's going to come up in March here. We're going to talk about that maximum thickness for perpetual pavement. We've learned some great things on that I believe is the 16th of March. Registration is open for that now, and we'll send a reminder out in a couple weeks. Given that, thank you, everybody. Thanks for joining us and helping us make this program successful. And as Buzz always says, have a blessed day.